In section 5, we're taking this idea of solving equations to a new level. So sections 1, 2, 3, and 4 just sort of build the process for how you solve equations using one variable and numbers. In section 5, we start bringing in more variables, and even to the point where there are no numbers at all, just letters. But the procedure for solving the equation is exactly the same. You just won't have an answer like x equals 5. You're going to have an answer like x equals some sort of other equation with a bunch of letters on the other side. And that's not that big a deal. You just need to remember the procedure, and you will get there. Okay? So first of all, we need to learn what a literal equation is. Somebody had this as a word for the vocab word wall. But a literal equation is just an equation with two or more variables. It's pretty straightforward. If you see two variables or more, it's a literal equation. A formula. You guys have used this word before, I'm sure of that. You've probably heard about the Pythagorean theorem, right? Pythagorean theorem is a formula. You may have heard the quadratic formula before. Has anybody heard that one before? A couple people have. That is a formula. It says formula right in the name of it, okay? A formula is just a special kind of literal equation. So I'll put that up there. So a formula is a literal equation. It's a literal equation because it has more than one variable in it, two or more variables, okay? But more to the point, a formula is an equation, so I'll put a little dash here, an equation that states a relationship among quantities. So a relationship among quantities. It's just a literal equation. They're basically the same thing. A formula is a literal equation. A literal equation is not necessarily a formula. It's kind of like saying that a square is a rectangle, but not all rectangles are squares. Okay? Square is also a rhombus, but not all rhombuses are squares. Same thing. Okay, so when you work with literal equations and formulas, you can solve for any variable. So in both of these things, we're using more than one variable in the equation. You can solve for any variable you want in a literal equation. You just have to follow the same rules for solving equations that we've been using all along. So that's using the methods you have learned for solving equations in this chapter. That's using the addition and subtraction, multiplication, and division properties of equality. Using the distributive property. Combining like terms. All of those things that we've done in the first 4 sections still apply here. Just now you're looking at letters and numbers instead of just one letter and a bunch of numbers. Alright, so we have this sign here, like we're standing on a sidewalk walking down the street in Boulder, Colorado, and we happen to see this sign. It says pizzas are $10, sandwiches are $5. You're going to order some pizzas and some sandwiches. You have $80 in your pocket and you want to spend all of it. How many sandwiches can you buy if you buy 4 pizzas? You just did it in your head, right? 8 sandwiches. What if you buy 5 pizzas? So that would be $50. You got 30 left over. So how many sandwiches can you buy? You can buy 6 sandwiches, right? So you can solve this problem in your head. Something else you can do is come up with an equation for this problem that you're solving in your head. You are actually already doing the math on your own. But now we're going to write an equation for it. And then we're going to solve for sandwiches. And then we'll be able to do the math easier in our head than what you're doing. So I need 2 variables here. This is a story problem. What are my 2 variables? P and S. What does P stand for? Not just pizzas. the number of pizzas that you buy. And then S stands for the number of sandwiches. The number of pizzas that I buy and the number of sandwiches that I buy will total how much money? $80. So I can write will total $80. How do I write the left-hand side? Nope. Thinking about it a little bit backwards. I'm going to buy a pizza. How much does it cost me? $10. What if I bought 2 pizzas? How much would that cost me? Why is it $20 now? Because each pizza is, so $10 per pizza, or in other words, $10 times the number of pizzas that I buy. The number of pizzas that I buy is P, so it'll be 10P. I'm going to have some sort of cost here, right? I have a number of pizzas times the amount that it costs me. That's a dollar amount sitting there. I'm going to add to that, what? 5S, because each sandwich costs $5, right? So I have sandwiches and each one of them costs $5. So notice that I have a number times an amount of money. That gives me money here, plus money here equals money here. Money plus money equals money. Dollars plus dollars is dollars. Is that true? Yeah. So I've set this equation up right. Okay, you can kind of take a look at your units that you're talking about, money, and see if it all makes sense. So now that I have 10P plus 5S equals 80, I want to solve for S. The reason I want to solve for S is because of this question right here. How many sandwiches can you buy? What you were doing in your head was you actually solved for S in your head, and then you came up with the answer from that. I want to do that now on paper. So if I want to solve for S, just like solving for X in some other equation that we've been working on, I need to get the S term by itself. So I got to get that by itself, which means I need to undo what's being done. What's being done to 5S? No, what's being done to this term? I'm adding 10P to it. So how do I undo add 10P? Subtract 10P from both sides. Once I do that, I have 10P minus 10P, which becomes 0. I have this positive 5S, so that stays. I didn't do anything to that. The equal sign comes down. And now I have this 80 and minus 10P. Are these like terms? No, because of that P sitting there. So I can't combine these. So I'm going to just write 80 minus 10P. Okay, so now the S term is by itself. I want to get just S, so what do I do to just S? Divide by 5. So I'm going to divide this by 5. And I'm also going to divide the right-hand side by 5. This whole thing right here is the right-hand side. And I'm going to divide it by 5. So I draw my division bar under that whole right side, and I divide it by 5. That gives me S on the left equals 80 minus 10P divided by 5 on the right. Now in the last couple of sections, we learned that we could rewrite this. Actually, it was the last chapter. We could rewrite this by taking that 5 and writing it out front, and instead saying it's 1/5 times these things. Remember that? What winds up happening is really what I have is 80 divided by 5 minus 10P divided by 5. Remember that? So that's what I'm going to do here, because I can see that these fractions that I'm going to write are going to reduce. So this becomes 80 over 5 minus 10P over 5. What is 80 divided by 5? Yeah, what is that? What? 9? 9 times 5 is 45, so it's pretty low. 15? 18? 16? Which one is it? 17. What is it? 16. 16 times 5? 6 times 5 is 30, carry the 3. 5 times 1 is 5, plus 3 is 8. That'd be 80. 16. So 80 divided by 5 is 16. Then I have the minus. What's 10p divided by 5? 2p. So I wind up with 16 minus 2p. So my answer here is going to be s equals 16 minus 2p. That is the equation now solved for s. We started with this equation, just in general. Now we have this equation solved for s. So, back to the problem. If I have 4 pizzas, I plug 4 in right here, and I do order of operations. I have negative 2 times 4, which is negative 8. 16 minus 8 is 8. And you guys told me I could get 8 sandwiches if I bought 4 pizzas, right? You did the math in your head. What you really did was this process right here in your head. So you already know how to do this. Isn't that weird? Doesn't seem like it, does it? Because this looks really complicated. But you guys actually already did that in your head. This is the formal process that you did. What about 5 pizzas? Well, I take 5 and I plug it in right here, and I get negative 2 times 5, which is negative 10. 16 minus 10 is 6. You told me I could get 6 sandwiches if I bought 5 pizzas, right? So this process right here works, and that's why we use literal equations. That's why we use formulas, because now we can solve these equations or these formulas for any variable we want, and then plug in information and get answers quickly. That's the whole point of this section. So let's use that idea now without the story problem set up. So we just are given this equation right here. It says 4 equals 2m minus 5n. That's the equation. And then they want us to solve the equation for that variable there, m. Then once we're done with that, they ask, what are the values of m when n equals these 3 values? So we're going to solve the equation for m. We'll have m equal some stuff. And then we'll plug in those values for n to find out what m would be. Okay? So first things first. Solve this equation for m, this variable right here. What do we need to do first? Yes, we need to get the variable term that we're looking for by itself first. That means we need to undo this minus 5n. So I add 5n to both sides. So on the left, what do I get? Yeah, that's a 4 there and a 5n there. Those are not like terms, so I can't combine them. So I just write them as is. I could write 4 plus 5n, or I could write 5n plus 4. It makes no difference. 5n plus 4 equals, what's on the right? The 2m. Okay, now we just got to get m by itself. What do we do? What is being done to m here? Multiplying. So we want to get m by itself, which means we need to undo multiply times 2, which means we need to divide by 2. I'm dividing the right side by 2, and I'm also going to divide the left side by 2. And notice how I did that. The whole thing is being divided by 2. Once I do that, I have 5n plus 4 over 2 on the left equals m on the right. Is the equation solved for m? Do I have m by itself on one side of the equation and everything else on the other side of the equation? Yes, I do. So we're done. That is the answer. Could I write m equals on the left side instead of on the right side? Yes, I could. That is the symmetric property of equality. Okay? This would be like the line of symmetry, and I can just sort of send this guy over here and send this guy over here. That's like symmetry. Okay, what's on one side is the same as what's on the other. So if I wanted to, I could write m equals 5n plus 4 over 2. And apparently I did want to because I just wrote it that way. What are the values of m when n equals -2, 0, and positive 2? Well, for n equals -2, I can substitute -2 in, and I get m equals 5, parentheses, -2 plus 4, all divided by 2. And then I use order of operations to simplify that down. I can do this in my head, actually. 5 times -2 is what? -10 plus 4 is? -10 plus 4 would be -6. Then -6 divided by 2 would be -3. So m equals -3 is the answer for when n equals -2. They want 0 also, so when n equals 0, I'm going to write m equals what? I got to write this stuff down like I did up here, so I'm going to write 5, what? Times 0 plus 4. Everything's divided by 2. So now I can do it in my head. I get m equals 5 times 4 is, or 5 times 0 is 0, plus 4 is 4. 4 divided by 2 is 2. And finally, they want n equals 2 as well. So I get m equals, what do I write? Yep. Good. So my answer, m equals 5 times 2 is 10, plus 4 is 14. 14 divided by 2 is 7. So m equals 7 is my answer for that case. Okay? Notice how nice it was. Once we solved the equation for m, all I had to do then was substitute, and then I could just solve these in my head. Okay? Down here it says, would it be better to just substitute n equals those values into the original equation? So 4 equals the original equation, 2m minus 5n. Now I want to substitute those values directly in without solving for m first. Is this going to be easier? Let's try the first one. I take -2 and I plug it in. So I'm going to write 4 equals 2m minus 5, parentheses, -2. So to solve this thing now, I multiply these two numbers together. 4 equals 2m plus 10. Then I got to subtract 10 from both sides. And I get -6 equals 2m. And then I divide both sides by 2, and I get m equals -3. So I got the same answer. Now we'll do the second one. We have 4 equals 2m minus 5, parentheses, 0. So 4 equals 2m minus 0, which is gone. So now I just have 4 equals 2m, and then I divide both sides by 2, and I get 2 equals m. I get the same answer. I'm out of room on the right side, so I'll move over here. Try the third one. 4 equals 2m minus 5 times 2. So now I got to multiply these two things together. All right, so I got 4 equals 2m minus 10. So then I got to add 10 to both sides. And I get 14 equals 2m. So then I divide both sides by 2, and I get m equals 7. I get the same answer every time. Which one's better? Which method is better? The first one? Why? Yeah, look at this. Once I have it solved for m, I can almost do the rest of this in my head. If I don't do that, I have to do the exact same process for every single point that I try. So every single number that I try to plug in. I have to solve the equation for m 3 times. But here all I had to do was solve the equation for m once. And then I could plug numbers in and do the rest in my head. That's why we need this section. That's why this section is incredibly important to you. Okay? This process right here is way better. What if I gave you a quiz and it was an equation like that and it said solve the equation for m and then find out what happens when n is equal to -4, -2, 0, 2, 4, 6, 8, and 10. You really want to solve that equation 10 times? No, you don't. Solve it once and then plug in and simplify it down. All right? Way easier.